Welcome back. We missed you guys. I hope you guys are ready for the good life, math life. And we're going to continue where we left off. Things are going to get a little interesting now. We're going to start speeding up a little bit, guys, because we've been going kind of slow, I think. But don't worry, you guys will be fine. Did I put one in there, Miss Anderson? Okay, yeah. All right, so here we go. Okay, we've done the last handouts. How will this look at the university setting? Well, we got some questions from the UH, and that is a university. So those anywhere you see UH, so those are questions that look like the university. And then when will I ever use these? Well, if you're an engineer, guys, or this is just a way to make trig functions like easier to simplify or easier to find out solutions. And you'll see what I mean. And then, of course, from here, this is like the introduction to double angles and half angles. We're not there yet, but we're pretty much almost there. So yeah. So let's look at this first question. It says, use the appropriate angle sum formula. That's relax. Angle sum formula is the same thing as what we've been doing lately. Composite argument properties. Composite argument properties. So that's what this is. We've been doing this for a while. To simplify the following expression, cosine 4x cosine 6x minus sine 4x sine 6x. Does that look familiar to something that we've seen in a formula somewhere? Yeah, this looks similar to this, guys. Cosine A cosine B minus sine A sine B. And that is cosine A cosine B sine A sine B is the same thing as, do you guys remember? Cosine A plus B. See? So the A in this case is a 4x, and the B in this case is a 6x. See? So I can rewrite this as one singular cosine, where the A is 4x and the B is 6x. And what's 4x plus 6x? So this is the same thing as saying cosine 10x. So maybe it's a lot simpler to use just cosine 10x instead of using this product of these two waves and these product of these two waves. And those are supposed to be equivalent. So let's see. Like, I don't want you guys to be robots because sometimes you guys are just robots and you guys just do stuff and you guys don't really know why we're doing them. If we go to desmos.com and we type in that initial formula that we have. So look, check it out. I'm going to type in... as soon as Desmos decides to, there we go. So look, cosine 4x, was it cosine 6x? And then was it minus sine 4x, sine 6x? So you see this wave that I have here, guys? Look, if I replace all that wave with cosine of 10x, look at that. It's the same wave. And what would you rather be dealing with if you're an engineer? Would you rather be dealing with the top equation here, this product, cosine 4x, cosine 6x minus sine 4x, sine 6x, or this singular cosine? Yeah, probably the singular cosine. So why is this important? Guys, waves are all around us. When we're talking, this is a sound wave with a frequency. I think it's 60 hertz. I don't remember. Maybe Google it. What's the frequency of our voice? Let's see. Frequency of our voice. Okay, never mind. Between 80 and 180 hertz. For men and 165 to 255 hertz for women, because you guys can have higher pitches, right? So there it is. Check it out. You can just Google anything nowadays. So yeah, guys. So our phones. This is a wave that's coming in here. Sometimes it's a radio wave, sometimes it's a magnetic wave. It just depends. What is 5G? What type of wave is that? Magnetic wave, spectrum. Okay, anyways, so I was about to Google it, but let's continue because then we'll just keep on going on the rabbit hole. Does that make sense of what we're doing there, guys? So let's see if you guys remember your formula. So we got this top one here, so I'll write it already. Cosine A plus B. And you guys told me that was cosine A cosine B minus sine A sine B. What do you think cosine A minus B is? Instead of a minus in the middle, I'm going to have a plus. So cosine A cosine B plus sine A sine B. All right. What about sine A plus B? Start with the sine. Sine A cosine B plus cosine A sine B. What do you guys think of sine A minus B? Same thing, except instead of that plus, it's going to be A minus sine A cos B minus cos A sine B. And then we got two more. These we won't really talk about them much, but they're just as important. Tan A plus B, that one is tan A plus tan B over 1 minus tan A tan B. And then using context clues, and I'll slow down. I can see some of you guys still writing, so let me slow down. Using context clues, if I switch this to a minus, then we just change the polarities of both of those. Tan A minus tan B over 1 plus tan A tan B. And that's what we did right before we let go for the semester. Do you guys remember that? I might give you guys back your semester exams because I put a lot of notes in them. I usually like to hold on to those, but I'll probably give it back to you guys. I just gotta scan them first. And I was generous with the semester exam, guys. The questions I don't know if you guys know this, but the questions that you guys were getting wrong as a whole, I made those the least amount of points. And the questions that you guys were getting right as a whole, I made those worth the most amount of points, therefore skewing the exam higher. You guys know what I mean? So, man, I skewed that semester exam so bad, guys. 1/3 binder, 2/3 semester, plus square root on the semester exam. Square root minus 5, but because I skewed it so much, so like the biggest curve ever. So no more curves. All right, here we go. Sorry for that little tantrum. All right, you guys ready? For positive acute angles A and B, it is known that sine A is 40 over 41 and cosine B is 24 over 25. Find the value of cosine A minus B in simplest form. And I put there what the answer is so we can know if we're doing it right or not. So look, cosine A minus B. Cosine A minus B, you guys already know this is just cosine A, cosine B, and instead of a minus, I'm going to put a what? Plus sine A, sine B. The secret to this, guys, I know what sine A is, so I'm going to put a check mark on sine A. And I know what cosine B is, so check mark on cosine B. I do not know cosine A, question mark, and sine B, question mark. I'm going to grab those. How am I going to get them? So let me circle this one in red. So if you have colored pencils, this will be a good one because I'll go ahead and do it in two different colors. And here's angle A in red. Chav, why is it in quadrant 1? Because they told me it's an acute angle. And I know that sine A is 40 over 41. So here comes a little bit of geometry. Sine is opposite over hypotenuse. So opposite of angle A is this guy, so 40. And then the hypotenuse, 41. Do you guys see how we did that? So I'm going to figure out this segment. All I'm going to do is use what theorem to figure that out? Pythagorean. A squared plus b squared equals c squared. I have the hypotenuse and I have a leg. So I'm going to subtract and square root. So I'm going to go square root of 41 squared minus 40 squared. Now don't be a robot, guys. Know where that comes from. A squared plus b squared equals c squared. I have a hypotenuse. I have a leg. So to get one of the legs together, you got to move one of the other ones. So square root of c squared minus b squared if you're solving for A. Does that make sense? All right. I take my calculator. Unless you know that is a perfect one of the triplets. Okay, let me stop talking about that. Maybe we don't remember that. And I'm just going to go, let's see, what was my hypotenuse? 41 and 40. I'm just going to go 41 squared minus 40 squared. And there it is. 9. See? Now from there, semicolon, I have cosine of A. Cosine of A is adjacent over hypotenuse, so 9 over 41. I'm gonna switch colors. I'm gonna go down this and I'm gonna circle this one in blue, and I'm gonna do that one in blue. So here is angle B, not to scale. There's angle B. Label your triangles, guys. Nothing crazy, right? Okay. I know that cosine B Cosine B, it's right here. Cosine B is 24 over 25. So cosine is adjacent over hypotenuse, so COTOA. Adjacent 24, hypotenuse 25. You don't have to do SOHCAHTOA all the time. If you already know what you're doing, just do 24 over 25. I need to figure out this segment here. Pythagorean theorem. Square root of 25 squared minus 24 squared. Come back with my little calculator. Bless you. Oh, that was a sneeze? I don't know. 25 squared minus 24 squared. And voila, 7. So this is 7. So now that I know that that's 7, I can figure out what sine B is. There's my semicolon. Sine B is opposite over hypotenuse, 7 over 25. All right, here we go, guys. How do we feel? Are we still okay? All right, here's what we wanted. So I'm going to write what I want. I want cosine of A minus B. I know that this is cosine A, cosine B, plus sine A, sine B. So down here in the bottom, right below it, I'm going to type what cosine A is in parentheses. Cosine A, here it is. Plug it in right there. 9 over 41. Cosine B, that one was given. 24 over 25. Plus, that plus is this plus. Sine A, there's my sine A right here. 40 over 41. Sine B, here's my sine B. 7 over 25. Is everyone okay, guys? All right, we're just going to type it in like this, exactly in the calculator with that formatting. If you type it in exactly like that with that formatting, the calculator is smart enough that it should give you that format as well. So I take my calculator, and I'm just going to go open parenthesis, alpha y equals enter, and I already forgot. What was it? 9 over 41. So there's my first one. Close my, let me get to the left here. Close these parentheses. Open another parenthesis, alpha y equals enter. What was the other one? 10 over 25? 24 over 25. Was it a plus or a minus? Plus. Plus, open another parenthesis, alpha y equals enter. What was the other one? I didn't hear you. What? 40 over 41. 40 over 41. Sorry, miss. That's because I hear a whole bunch of hums. I hear the hum of this AC and I hear the hum of that AC. The air, the frequency, the line of sight is 10. Like it's okay. I'll stop. What is the last one here?
7 over 25.
7 over 25. If you do the formatting like this, the calculator should be smart enough to give you the same formatting again. Bam! Look at that. The calculator gives it to me in a nice little fraction. Do you guys see that? So 496 over 1025, is that what I have way over there in that little corner? And there it is, check mark. Do you guys like these notes when I write the little ant, like we know what we're supposed to get? Is that a good change? Okay, I'm trying to make the notes better for you guys, you know? Oh, by the way, your binder check, guys, your binders were all over the place. I was so generous. Do you guys ever buy, do you guys read novels? Do you guys read books? Do you guys like to buy books? Do you ever buy just a book and the pages are all over the place and you have to find stuff? Like this, oh man, where's chapter 3? I gotta go look for it. No, then guys, fix your binders. Make it like, okay, you can be honest with yourself. I guess next time tell me that you just don't use your binder because I can tell. Tell me you don't use your binder and then I'll just give you 100, I guess. The whole point of a binder check is that you're referencing your binder. Notice your average. I was very generous with averages this quarter, guys. But if your average is not up to par, it's probably because you're not making use of your notes. Like, how do you reference stuff, you know? Are you referencing everything online? I mean, I don't know, maybe. But if you're not going to use your notes, then why even take notes? Do you guys know what I'm trying to say? So take better notes, please. Look, I'm going to put the dates on all of them. So worst case scenario, at least put it in by the date. Just put it in order by date at the worst case scenario. So please put your binders in order next time, guys. Okay. Sorry, that wasn't mean, was it? I was just letting you guys know. All right. Here we go. Let's go to the next one. Did all that make sense, by the way? Are you guys tired? Is your sleeping schedule back to normal? No? Okay. Sine A is 5 over 13, tan B is 40 over 9, and angles A and B are in quadrant 1. Find the value of tan A plus B. So here we go, guys. Ready? Tan of A plus B is equal to tan A plus tan B over 1 minus tan A tan B. You only need one of them because look, they already give you tan B. So I already got tan B. The only one I need now is which one? Well, tan of A, right? So I'm going to, no, you're good. I'm going to use sine A to get my tan A. So here it is, quadrant 1. Here's angle A. And sine, I have 5 over 13. Sine is opposite over hypotenuse. So to get this segment, I'm going to go square root of 13 squared minus 5 squared. So I take my calculator. So see, I'm just using geometry here, guys. So you can see why all these math courses are important. Square root of 13 squared minus 5 squared. And there it is. You get a 12. So this is 12. And some of you are probably not surprised. It's one of those. Let's just go. All right, so here we go. What is tan A? Tan opposite over adjacent. So it's 5 over 12. Not everyone at the same time. Happy birthday, miss. Are we okay? All right, here we go. 5 over 12 plus, Chop, where'd you get that from here? Opposite, SOHCAHTOA, guys. Opposite over adjacent. 5 over 12 plus, what is tan B? 4 over 9 over 1 minus tan A, which is 5 over 12, times tan B, 40 over 9. That's a parenthesis. Type that into the calculator exactly how it looks. So let's take my calculator, Chop, but there's fractions within fractions. You're fine. Look, alpha y equals enter, and then put another fraction right there. Alpha y equals. See? What was that first one? 5 over 12. So 5 over 12. And then plus what? 40 over 9. All over 1 minus, parenthesis, and then 5 over 12. Alpha y equals enter. 5 over 12. Make sure the format looks like this, guys, or else the calculator's not going to give you that pretty format. Open, and then 40 over 9. Alpha y equals enter. 40 over 9. And if you did everything correctly, the calculator should leave the format the same. And look at that. Is there a negative 525 over 92? Man, how are we feeling? We feeling okay? Okay. All right, let's keep going, guys. Don't worry, we don't got that many left. We just got 3 more questions, and then we'll call it a day. All right, question 3. Given that sine x is square root of 13 over 6 and cosine y is square root of 23 over 5, and the angles x and y are both in quadrant 1, find the exact value of sine x minus y in simplest radical form. So this is going to be a little harder because of the irrational, but relax, it's not that bad, guys. So here it is, angle 1. Here's angle x. And sine x is equal to square root of 13 over 6. So there's my sine x. What I need is cosine x. So how do I get this value here? Square root of 6 squared minus square root of 13 squared. Now I know some of you guys can probably do this in your head. This is not going to be a perfect integer, a perfect square root. So you're just going to do the inside and then see if, Chop, what are you talking about? Like this. 6 squared minus square root of 13. Let me put that in parentheses. Square root of 13 squared. Now I know a lot of you know that square root of 13 squared is just 13, and 36 minus 13 is just going to be 23. But there it is, and then that's not a perfect square root, because if I were to go square root of 23, because remember, all this is inside that square root, I get 4.79. See? So it keeps going forever. So this is square root of 23. Leave that at square root of 23. I'm going to do this one in blue. So here it is. Label your right triangles. I'm in quadrant 1. There's my right angle. This is angle y. And they give you cosine. Cosine is adjacent over Hypotenuse, so square root of 23 over 5. There it is. So to get that, the vertical displacement there, I'm going to have to do square root of 5 squared minus square root of 23 squared. Now, I guess you could, if you wanted to, put this inside the calculator, but 5 squared is 25, and square root of 23 squared is 23. And what's the difference between 25 and 23? 2. So there it is, square root of 2. Remember that square root is still there, guys. Yes, you could use your calculator if you want, but, I mean, you can do it. You don't need it. See? And then square root of 2, it's not an integer. It's irrational. Goes on forever. Kind of like square root, like pi. All right. So leave the square root there. We're ready. What did they want? Sine x minus y? Is that a minus in there? Yeah. So here we go. Sine x minus y. You guys remember the property? Plus or minus? Minus cosine x sine y. Put the value in the bottom. So here it is, parentheses, sine x. Well, I'm looking at this x here, square root of 13 over 6, open parentheses, cosine y. Go to the y. I think that one was given. Square root of 23 over 5 minus cosine x. Go to this one, square root of 23 over 6. Square root of 23 over 6. Sine y. Go to the y. Square root of 2 over 5. Is everyone okay with where we're getting those numbers from? Okay. 6 times 5 is 30, so leave the 30 in the bottom. Square root of 13 times square root of 23. Do not do this, guys. Do you guys remember law of exponents? Oh, man. Okay. Side note. Square root of A times square root of B. I don't know how your teachers taught you, but I'm sure they taught you this eventually somewhere. Maybe they said, like, that's inside the house or whatever, and this is inside the house, or I don't know, whatever they did. So if they're both inside the house, then they both stay in the house. So square root of A times B, something like that. It's just a law of exponents, guys. It's not just for that. It could be for anything as long as the exponents are the same. Cool or not cool? All right, so it's the same logic with this. So 13 times 23, take your little calculator. 13 times 23. And we get this number, 299. That is not a perfect square root. See? Square root of 299. Enter. Bam. So leave it at square root of 299. Square root of 299. That's a 9 there. Minus 6 times 5 is again 30. So that's the denominator in the top. 23 times 2, 20, 40, 46. Square root of 46. 46 is not a perfect square root, guys. Square root of 46. See? And then 23 is not a perfect square root, and 2 is not a perfect square root. So there it is, guys. And that's it. That's the answer. Leave it alone. They're both to have a denominator of 30, so square root of 299 minus square root of 46. All over 30. That's 46. Is that what it says for A and S? What do you guys think? Are you not entertained? All right. Let's go to the next page. And before we start this, you are going to have a UH quiz. The reason why I'm sighing, it's not because it's not like, I don't want to give you the UH quiz, guys. It's because when I assign these UH quizzes, let me let you guys know in advance, you're not helping yourself if you use Wolfram Alpha or AI or ChatGPT. If you're using it the right way, then you're fine. But a lot of you guys are not using it the right way. And I know that because you guys get hundreds on these UH quizzes, and then I put the same questions on the exam, and you just bomb them. Remember, I don't get full credit if you just circle the right answer. Like, I gotta see work, guys. Like, I have to. Like, those, I don't deny the fact that maybe you can do some of them mentally, but when you take any exam at the university, at the AP exam, guys, they're like the free response. You have to show work. If you don't show any work, they're not going to give you an answer. And there's something called the bald answer, meaning that if you get the right answer, but there's no work signifying evidence for the answer, they don't give you any points either. Not even for the answer. So, do you guys understand what I'm trying to say, guys? So I would try to do this the honest way and not try to use ChatGPT or Wolfram Alpha or anything. I mean, I guess you can if you use it the right way, but if you're using it just to get by and turn in some assignment, then we're not doing it right, guys. So check it out. It says find cosine x plus y. This is coming from UH. It's the same logic. I'm going to write cosine x plus y, and I just write the formula for cosine x plus y. Cosine x cosine y minus sine x sine y. Are we still okay? Nothing crazy, right? All right, check it out. It says cosine x is in quadrant 1, because that's what it means. Means angle x is in quadrant 1. So here it is. Angle x, quadrant 1. Cosine is adjacent over hypotenuse. Adjacent, 1. Hypotenuse, 6. So how do I figure out this segment there? It's the square root of 6 squared minus 1 squared. 6 squared is 36. 1 squared is 1. So square root of 35. So there's 35. Square root of 35. Is everyone okay with how I got that, guys? All right. I'm going to do the other one in blue. It tells me that y is between 270 and 360. That is this. So this means angle y is in, what quadrant is that? 4. So here it is. I'm going to exaggerate quadrant 4. There's my reference triangle. This is the real angle y. This is your real angle y, but I'll use your reference to help us out. So we put y there. Does that make sense? Cosine is 1 over 4. The hypotenuse is never negative. So 1, 4. So to get this segment, it's going to be a negative square root 4 squared minus 1 squared. Chop, why'd you put a negative in the front? Everything in quadrant 4, all the y values are always going to be negative. Not to be confused with the angle there. That's angle y. So 4 squared is 16. 1 squared is 1. What's the square root of 16 minus 1? Square root of 15. So leave it as negative square root of 15. We're still okay? All right, here we go, guys. Equals. I'm just writing this. Bless you. I'm going to write cosine x on the top, and I'm going to write what cosine x is. So bless you, bless you, bless you. Cosine x, adjacent over hypotenuse, 1 over 6. It was given. Cosine x, cosine y. Cosine y, I go to the y one, that was given, 1/4. And then minus, so minus, and then minus what? Sine x. So I'm going to write what sine x is. I come to this one, so square root of 35 over 6. And then sine y. I go to the y one, the blue one, opposite over hypotenuse. So negative square root of 15 over 4. Is everyone okay with that? First thing I'm going to do, negative times a negative is a... That's the only one that I can delete right off the bat. Do you guys see that? 1 times 1 is 1. 6 times 4 is 24. Do you guys see that? Plus, Chop, how am I going to do that? Well, it's inside the radical, 35 and 15. I take my calculator, 35 times 15. And it looks like it's 525. Ooh, we're probably going to have to do special something here. So let's see. Square root of 525 over 6 times 4 again, 24. Chop, I don't see that answer in there. It's in there, guys. 525 is the same thing as 25 times. How many quarters do you got to have $5.25? 4, 8, 12, 16, 20, 21. 25 times 21. Do you guys see how we got that, guys? If you have 21 quarters, you have $5.25. So 25 times 21 is 525. What's the square root of 25? 5. So there it is. So this is, the denominators are the same. 1 plus 5, square root of 21, all over 24. Did you guys think that was tough? Okay, that's what's coming up next. Let's do one more, and then we'll set you guys loose. I know you guys are tired. Relax. We'll be fine, guys. Last one. Sine x. So this is telling me that 3 over 10 if angle X is between 90 and 180, what quadrant is that? That's quadrant 2. And I'm just going to do all this in the same color. Is that okay with you guys? And then sine Y is in 180 to 270. What quadrant is that? Quadrant 3. So here we go. Quadrant 2. I exaggerate it. This is my real angle X. But we're going to use this to help us out. Sine is 3 over 10. So opposite, 3. Hypotenuse, 10. So this guy right there is the square root of 10 squared minus 3 squared and a negative on the outside because we're in quadrant 2. 10 squared is 100. 3 squared is 9. And 100 minus 9 is... Yeah. And put a negative on the outside. Okay, I'll do it with different colors so it can stand out more. I'm going to do this one in blue. 180 to 270. So 180 to 270 is in quadrant 3. So here's quadrant 3. Here's angle Y. It really is this one here, way over there like that. But we're going to use that one to help us out. Opposite over hypotenuse. Put the negative with the vertical displacement. The hypotenuse is never negative. Well, for now. When we do polar, it can be. But the hypotenuse is never negative, guys. Are we still okay? All right, so here it is. That's 3. So to get this segment here, square root, and it's going to be a negative, right? 3 squared minus negative 2 squared. You don't have to put the negative because it's gonna turn back to a positive anyways when we square it. 3 squared is 9. 2 squared is 4. 9 minus 4 is 5. So negative square root of 5. So this distance here is negative square root of 5. We're almost done. We're so close. Here we go. I'm going to go back to red. They want sine of x minus y. So I'm going to write what sine x minus y is. Sine x cosine y minus cosine x sine y. We're still okay, guys? All right, here we go. Sine x. I go to the angle x. 3 over 10. I think that was given anyways. Cosine y. Go to the y. Negative square root of 5 over 3. Because cosine is adjacent over hypotenuse. Is everyone okay with that, guys? Okay. Minus cosine x. Go back to the x. Negative. Well, never go back to the x. But in this case, we're solving for x. So negative square root of 91 over 10. I mean, they're an x for a reason, right? Don't go back. You're just asking for trouble. Sine y. Go to the y. Negative 2 over 3. Negative times a negative is a positive. So that minus sign stays there. So let's see what we got. Well, I'm talking about this one. In case you were thinking about maybe that one. Sorry, guys. I should have been more specific. 3 times negative square root of 5. So that's going to be a negative. Negative 3 square root of 5 over 30. Minus 2 square root of 91 over 30. So I'm going to look for that answer first. Do I see it? No. They reduced it. I don't like that they reduced it, but that's fine. How many times does 3 go into 30? 10. So negative square root of 5 over 10. Minus, how many times does 2 go into 30? 15. Square root of 91 over 15. Let's look for that. And it is in there. It is what letter? It's in there, guys. Which one is it? Yeah, D as in Darren. 1/10. There's a 1 in front of that. I don't know why they did it that way, that format, but there it is. How do we feel, guys? Okay, I haven't assigned officially the UH quiz yet. Let me look at it tonight. If you want to get started on it, if you have nothing else to do, then yeah, go ahead, start on it. But you do have a Delta Math. So yeah, let's just take care of the Delta. The Delta Math is easier because it's all in quadrant 1. And then if you have extra time, log into UH and try the one that says Trig Identities 2, I think. Well, I haven't assigned it yet, but it'll probably be due next week. All right, guys, we're done. Log into Delta, please.